The German architect Mies van der Rohe coined the phrase "less is more" in his pursuit of designing beautiful, elegant buildings with a reduced feature set. Indeed, his whole approach to architecture really started the minimalist movement. Now, as software engineers who, let's be honest, have lifted so many terms and concepts from the building and construction industry, can we take a minimal approach to building our applications, and in this case, APIs? Well, in today's video, we're going to do a full step-by-step build of a minimal API and then contrast it and compare it to an MVC API. And by the end of this video, we'll find out whether less really is more. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia as usual. And when is it? It's May 2022. So I hope wherever I find you and whenever I find you all very happy, safe and well. So in today's video, yes, we're going to be doing a full step-by-step build of a minimal API. And minimal APIs were something introduced as part of .NET 6, so I thought it would be a good topic for one of my videos and hopefully an interesting one for you all as well. Now, moreover, more than just doing the step-by-step build of the minimal API, we're going to then contrast and compare it with a more traditional MVC API and look at some of the features that are very similar, exactly the same, and some features that are not there, and allow you to make the determination whether that's a big deal or not, and allow you to choose which pattern you're going to choose for your own projects. So just before we move on to today's video, just a little bit of housekeeping. The code, as usual, is on GitHub, so if you want to just go and pull that down, you're more than welcome to do that. Time codes for the video are in the description below. It's another quite long video, so if you want to jump around or skip back and forth, time codes are the way to do that. If you like the video, think about giving it a like, that just helps me out. And if you've not done so already, maybe think about subscribing, ding the wee bell, and you'll be notified of any content that I make. Other than that, thank you all for stopping by and watching. To my Patreon supporters, your names are coming up at the end of the video, and once again, thank you to you all as well. But let's not delay any further, and let's get started with building a minimal API. All right, hello and welcome to episode 3 of season 5, and today we're talking about, I think, a very exciting subject, which is minimal APIs in .NET 6, and maybe a bit more specifically what they are, why you would choose to use them, and really the main thrust of today's video, how they compare to the MVC-based APIs that have gone before them. We're going to be taking a look at how they compare. So this is what we're going to cover in today's video. We're going to look at what minimal APIs are and some alternatives, or the main alternative within the .NET landscape, which is MVC controller-based APIs. We're going to do a full minimal API step-by-step build. So we're going to have read, write, destroy, and update actions. We're going to use object mapping, repository patterns, so pretty much a full step-by-step build. And then we're going to compare it to a controller-based, MVC controller-based .NET 6 API, which is basically doing the same thing. And I'm going to call out the main differences, not every single difference, but the main key differences between the two patterns and approaches. So if you want to follow along in today's video, or with today's video, you will need the .NET 6 SDK. So .NET 6 is mandatory in this case. Minimal APIs are an innovation with .NET 6, so you'll need that version of the framework. Any text editor or IDE, but I'm going to be using VS Code, which is free. An API client, so we're going to be testing the APIs, so you can use a web browser if you want, but I would definitely recommend either one of these, Insomnia or Postman, both of which are free. I'm going to be using Insomnia today. And then Docker or Docker Desktop, which is free. And the only reason that I'm including that is because we're going to stand up a SQL Server database. If you already have a SQL Server database running in some other way, that's fine, just use that. Or you want to set SQL Server up in some other way, that's fine, do that. I'm just including Docker here because that's how I'm going to set up a new instance of SQL Server. It's nice and easy and straightforward. All right, so with that, let's take a look at what are minimal APIs. So what are minimal APIs? Let's take a look at a quote from Microsoft, and this has been lifted from their online tutorial actually, some of which this video is based upon, but I've put my own flavour on top of it, of course, as I usually do, but this is lifted from that tutorial, and it's a good description of what minimal APIs are, and they say minimal APIs are architected to create HTTP APIs, which is fairly common, with minimal dependencies. Okay, so low code, low dependencies. They're ideal for microservices and apps that want to include only the minimal files, features, and dependencies in ASP.NET Core. So quite a good description. Basically what they're saying is, if you want to create small, lightweight, minimal-based APIs that don't have a lot of dependencies on other things, that maybe don't need to have a huge feature set, then minimal APIs are a good way to go. They're quick, they're light, they're easy to set up and run with, as compared and contrasted with the MVC approach that's been taken with APIs in the Microsoft.NET framework up until now, and still exists today. So by the way, these are not a replacement, they are complementary. So the whole point of today's video is to take a look at minimal API build, and we'll contrast and compare that with an MVC controller-based API build, and we'll look at the features that are identical, and there are lots that are very similar or exactly the same, and there are features that are not there in the minimal API, and that's really what we're going to focus in on today, or certainly, in my view, the most important ones. There's a whole range, but I'm going to just cover the main ones from my perspective that you may think you're missing out on, or maybe not, and that's entirely up to you. So by the end of this video, you should have a good idea of which pattern you want to use, minimal APIs in .NET or the MVC-based APIs, and they both exist at this point in time and probably will continue to exist side by side going forward. So one is not a replacement for the other. They are very much complementary. So with that being said, we're going to take time out on the conversation around minimal APIs, and we're going to look now at a bit of a refresher on the MVC pattern. Okay, so this is again focusing on the more traditional way of writing APIs in .NET, which is using the MVC pattern. So we're going to take a quick look at that now, just to refresh us, so we've got a good basis on which to progress and understand the real differences between MVC-based controller APIs and minimal APIs. So we'll do that next. All right, so quick diversion into MVC. And again, just to stress, again, this is nothing to do with minimal APIs directly. We're using this exercise purely as a method to contrast when we do come on to talking about minimal APIs. And some people watching this video may not know even what MVC is, which is fine. And again, it's kind of why we're doing this review. So it stands for Model View Controller, and on the next slide I'll go into more detail on what those are and how they interact with each other. But just more generically, MVC has been around a long time, created at Xerox PARC in the late 70s, so almost as old as I am. So yes, been around a long, long time. It splits the program logic into three, very importantly, interconnected elements, which of course is the model view and the controller, and very, very widely adopted in many different web development frameworks using different languages. So not an exhaustive list here by any means, but things like Ruby on Rails, which I've done a little bit of personally, but not that much. Spring, which I believe is in the Java world, I've not done anything with that. Django, Python, I think, again, not done anything with that. And of course, our favourite, ASP.NET MVC, which more than likely is going to be using C# or one of the .NET languages. But again, point here, widely used and still widely used. So I don't want you to get the impression that it's redundant or being deprecated or anything. That's still very, very widely used indeed. So these are the three components: your models, which are basically your data structures that model your data, the view, which is a display of that data to the user, and then the controller, which really maps requests to actions. Think of those as API endpoints, and it does something with those actions, or in those actions. And it's really like an orchestrator, basically. It's kind of, in my view, kind of the central, it's the central component of this pattern. So the way it works, requests will come from the view, so user sending input to the controller from a user, the request will be mapped to an action, and then the controller will manipulate a model as a result of that action. And then the model will update the view Now, occasionally the controller will directly update the view, but for the most part it's driven from the model. And that's kind of how the three components interact. And you might go, why do we have these three components? Well, it's a typical decoupling argument. You decouple your system into different components that do one thing and do one thing well, and it just means you can focus on those components as and when needed, and they can, you can make changes to different components as and when you like, rather than it being part of one big homogeneous lump of code. It just split things out, makes it easier to maintain, is the theory anyway. So from the perspective of a ASP.NET MVC API, it's a bit of a mouthful. I'm just going to take you through one architecture that you will see a lot, and this is an architecture I've used in my previous videos, most notably the large video on building one of these things, an ASP.NET MVC API in, I think it was .NET 3.1. It's not changed that much. There's one minor difference on this architecture, but this was the pattern that we used there. And I'll call out some optional items in this architecture. But again, this is looking at the MVC-based APIs, and we'll contrast it with the lightweight API in a couple of slides' time. So we'll have a program class. In the original video I did on Framework 3.1, there was also a startup class, but that has kind of gone. I think with .NET 5, they kind of took out the startup class by default. So you just have your program class. You'll have your models, which are our internal representations of our data, the M in MVC. You have your controller, which is responsible for mapping requests to actions, C in MVC. We'll have our request pipeline, our middleware, and that's where requests will propagate through. We will have a DB context, as we're using Entity Framework Core in this case, and SQL Server, denoted by the database there. And the whole point behind the DB context is to act as as it says there, act as a mediator between our internal models, the stuff held in memory within our app, and mediating it down to our persistence layer, which in this case is SQL Server. That's really what the DB context is responsible for. So in terms of a workflow or a data flow, you'll have your client, can be anything, can be an application or a test client or anything, making a request for some data. So let's say we want to fetch some data using one of the API endpoints. So request will come in, propagate through the middleware. If we're using controllers, then it will hit our controller, and our controller will determine the right action at that point. Now, the controller talk directly to the DB context to return data. In this case, I'm not doing that. In this video, we're going to be using a repository. So we're going to be building a very similar model with minimal APIs. Again, this is a controller-based approach, but we'll be taking a similar approach with the minimal APIs. So we're going to have a repository, or you can have a repository. The controller will talk to the repository, and that will then in turn talk to the DB context. The controller can talk directly to the DB context though. And I have had some comments from some viewers saying, repositories are one point of decomposition too far. It's just too many layers, and that's fine, that's your view. I respect that view, of course, but I kind of like the use of the repository pattern. It's that persistence ignorance, it's often called, so you can swap out DB context if you want, and just your repository will stay in place. And then a further way of decomposing things is not returning your models back directly to the client. You can do that, of course, but I like to use data transfer objects, which are external representations of our models to a client. And the idea behind that is that you may not want to expose, and you really probably shouldn't directly expose your models to an external client for lots of reasons. Security reasons, there might be attributes on there you shouldn't be exposing. It also means that if you're exposing your models directly, they're kind of forming part of your contract with your consumers, and it makes it harder to change as well. So if you want to change your internals, you've kind of coupled your internals to external clients. It makes it a lot harder to change. So by using a representation of your model, a DTO, you can kind of change your internals and then map those changes through, or not, to the DTO. So it kind of gives you that nice decoupling. So if I was to choose between, do we do a repository or do we use DTOs, I would definitely go with DTOs. We're going to do both. But if I had to gun to the head, you can only do one, I would go with DTOs over using a repository, definitely. But we're going to be doing both in today's video. And then you return the serialized JSON back to the client. So again, we're really focusing on MVC. The point here is that we have a controller in place, and the controller is acting as this kind of orchestrator of requests, mapping it through to actions. so on and so forth. You might go, okay, we've got a controller, we've got our model, we've got the M and the C, but we don't have a V. Where's the V? Where's the view? Well, really the view would probably be sitting over here somewhere. Some people could argue or do argue that the JSON being returned is really analogous to a view. I think technically, if you're keeping in the spirit of what MVC is about, that's not really true. Probably depends on the context, but you could argue that it is a view, but I think technically it's not. So really, it's not even the MVC pattern. This is an MC pattern, model and controller pattern, in terms of APIs. So the big question, what does all this have to do with minimal APIs? I've kind of already covered it. Really, minimal APIs don't have a controller. Okay, they don't use a controller, and generally they don't use the MVC framework as a whole. So I've honed in on the controller component, but really, minimal APIs do not use the ASP.NET Core MVC framework. So what does that mean? What does that mean? Why is that a big deal? Well, it means that minimal APIs are, be careful with my words here, do not have some of the features that come baked in with ASP.NET MVC. That framework's evolved over a long time. It has a lot of features built into it. By not choosing to use the MVC stuff, you're kind of removing a lot of those features being available to minimal APIs. And again, at the top of this video, that's really what we called out, or Microsoft called out. It's a lightweight feature set. So minimal APIs don't support model validation out the box, which is possibly the biggest one for me. They can have validation, but you have to add that in additionally, specifically. You know, it's not baked into the framework. So out the box, you don't get it. Don't support JSON patch, which is kind of the ability to have an endpoint that allows you to update components of a model rather than the whole model, which you would get with a put endpoint. Don't support filtering. And I'll talk about filtering. We're going to go through all these in a lot more detail later, and don't support custom, and I'm really putting that in big letters, custom model binding, and really it's support for iModel Binder. Now, these are not the full list of things that minimal APIs don't support. They put the URL down here. Again, it's the minimal API tutorial, and at the bottom of that article, it lists out all the things that minimal APIs don't do. I've picked these 4 because for me, these are the most important ones, are the ones that you might be questioning about. I've put these in my personal order of importance, with custom model binding being last. But again, we're going to go through all of these as we move through today's video. And you may disagree with my ordering here. You may think custom model binding is much more important than being able to support JSON patch. Up to you. I put them in that order. When we tackle them and we look at them, we're going to take a different view. We're going to take a more logical view of how each of these things interplays. But for now, we're really almost ready to move on to parking all this for the moment and getting ready to do our MVC, no, not our MVC, doing our minimal API build. So just before we move on to that, here's a contrast between what we're going to build today, our minimal API, and what I just showed you before. So I've already gone through this before. Here's what we're building today. So we still have a request pipeline. Still going to have DTOs, repositories, data access, models, all this stuff you can see here, absolutely identical. Identical, okay? What is going to be different is the fact that you can see here we just have a program class in this instance. There is no controller, okay? And that really fundamentally from an architectural point of view is really the only difference. When we start building it though, I'm going to start to call out more differences, but purely from that 50,000 foot level, that's what our application is going to look like. We are going to contrast and compare a minimal API with the MVC-based API. I'm not going to code that. I already have that code written. It's available on GitHub for you to pull down, as will the minimal API code as well. But unlike most of my videos where I code everything from scratch, we are going to do that with the minimal API completely from scratch. But the MVC-based API, I'm just going to reference that because the video would be way too long if I built that as well. And as you can see here, there's so much similarity and duplication that it would be a total waste of time anyway. So the approach I'm taking is just to call out the differences in the MVC app, and we'll just look at the code that I've already written. So hopefully that is an acceptable approach. So with that, I think we are ready to move on to starting our build. All right, so let's go on and start our build. So I'm just going to start a new instance of VS Code Fantastic. And I'm going to move into my working directory, so Control and backtick. And my working directory is somewhere on my OneDrive. It's a massive long path, so I've just got an environment variable that I have configured. So you don't need to do this, of course, but I'm just going to use my environment variable to episode 03, and that will take me into my code folder. So move into your working directory where you're going to build your project. I'm just telling you what I'm doing here, just in case you think, what is that he's doing? I've got a couple of folders in here already, some of the prep code that I've been working with, and in fact the MVC API is in here, and I've got some archived code, but for the most part this is where I'm going to build our minimal API. So .NET new, we're using the Web API template, but most importantly we're going to use a minimal flag, -minimal, and then we'll give our application the name of 6min API. Okay, so .NET new Web API -minimal, which is this new minimal API that's been introduced with .NET, and we'll give it a name of 6min API. And we'll run that up, do a quick directory listing, and you'll see we have our folder for our project, and I'm just going to open that in my instance of code, so code 6min API, and actually I'll use the R flag. I'll probably put the R flag after it, but that just means we're going to open it in this same instance of code. VS Code, there we go. Fantastic. So as we move through the video, we're going to contrast and compare it with the MVC based API. Just click yes to that to add those in. But you can see here it's fairly lightweight. We have our app settings JSON files, we have our program file, and we have our CS proj file. So no controllers, nothing like that out of the box. And if we come in here, you'll see there's a whole bunch of stuff that basically is a bit of a default template for this minimal API, and it just returns some randomized weather data. So perhaps the first thing we should do is just check that this is working. So control backtick, and we'll just do a .NET run, just to run it up. Make sure it's working. And the only issue you may get is maybe something around HTTPS. If you've not got a self-signed certificate, you might get an issue along those lines. I'll put a comment or I'll flash up a command that you can type to generate a self-signed certificate if you get anything around HTTPS being an issue, but for the most part that looks pretty good. All right, now I'm going to use Insomnia to test our endpoints. So before I do that, I will just mention I'm using something called, what's it called? Microsoft Power Toys. So it gives us access to this Power Run feature. So I've just got it configured using my Windows key and typing space. And in fact, if I bring it up, I can show you what I'm talking about. Microsoft Power Toys. Here we go, Power Toys. You can get it from the Windows Store free of charge, and it gives you access to a whole range of different cool tools that just enhance your experience. And I'm using this Power Toys Run feature that just brings up that box where you can type in anything you like and it will search for files or open up apps or anything like that. It's pretty cool. So I'm going to use a tool called Insomnia. Again, Insomnia is free to download and use, and I'm going to use that to test our API. So it's just started on my other screen. Now what I've got in here is I've got a whole range of actions, test endpoints, test actions that I will work or use with our MVC based API that I have already built. We're not going to come on to that yet. I've just got those parked there, and I will make this collection available for download as part of the GitHub repo, but you can build them yourself as you go along, and they just basically test out our API. But what I want to do first of all is just test our minimal API. So first of all, I'm going to create a new folder just to keep things nice and separated. Call it minimal API. That will create a folder, and I'm going to create a new test request. It's going to be a GET request, and we'll just do test weather. So we're just going to test the default functionality just to make sure that it's all working smoothly. So it's running. I'm just going to copy this endpoint, the HTTPS endpoint, and I'm then going to make sure that I browse to this endpoint here. So we're going to go through this in a lot more detail when we build it, but here's an endpoint that's already been mapped effectively to a GET request, and it's residing at this location here, /weather forecast. So we come back over here and paste in our base URL, and then we just type in the actual endpoint. We should get some data back, and I think I just spelled that wrong. Forecast. There we go, and we get our weather back. So that's our API working, minimal API working, fantastic. We can get rid of this now, we don't really need it, I just wanted to test that. But we'll leave the folder there because we're going to basically build out a range of tests for it as we build each endpoint. Control C on that for the moment, and I'm actually going to basically take out a lot of the default code. So I'm going to take out these comments, I'm going to leave this stuff in here, take out that comment, I'm going to leave this in here. That just gives us access to Swagger, which we're not really using today. I'm going to take this out, we're not making use of it. I'm going to take all of this out, which basically renders our API completely useless. And I'm going to take out this record as well, which is kind of analogous to our model. And that's it. That is basically our starting point for a minimal API. That's really all the code we've got. Everything else is basically just config. So we're setting up our services, anything we need to use through dependency injection is kind of done up here. And then our request pipeline's been set up, and then we run our app. So we're going to use this as our basis on which to move forward. Fantastic. But before we move on any further, I'm just going to include some package dependencies that we're going to need with some of the features that we're going to introduce. So we'll do that next. All right, so let's just come on and add a few additional package references into our project, mainly for Entity Framework and using SQL Server, and also for something called Automapper, which is a mapping framework that allows us to map between our models and our DTOs. Very good framework. So without further ado, .NET add package, and the first one we want is Microsoft Entity Framework Core. And I've got my CS_proj file open just so I can see these references being added. Sometimes it's easy to mistype these things, and if you're not paying attention, they don't get added. So that's why I'm doing that. So up key, and we're going to add append design to that same package. So it's a separate package, obviously, but to save you typing, just do an up key, and we'll add in the design components, and then remove design and add in SQL Server. So Microsoft Entity Framework Core.SQL Server. And we should see all three of those being added. And then the last package we're going to add is for Automapper. So it's not from Microsoft, so delete up to the point of .NET add package, and we'll add Automapper extensions .microsoft .dependency injection. So quite a long one. Easy to mistype, but I think that looks okay. We'll find out if it's not. There we go, it's added it in. So Automapper extensions Microsoft dependency injection. And that includes the main Automapper package, but we want to make use of the dependency injection features. So we'll just include this package instead. Fantastic. Now, the other thing I'm going to do is we're going to have a connection string that will allow us to connect into a SQL Server. I'm going to use user secrets to store our password and user ID. So I want to set up user secrets as well. So in order to initialize that, it's .NET user -secrets init. Init. And what that will do is it will add a new attribute into our property group with a unique identifier in there. Now, I'm just going to use user secrets in this video. I'm not going to go into any detail about how they work and where they're stored and anything too much detail about configuration. If you want to have a deep dive into user secrets or dependency injection for that matter, pop over to lesjackson.net, and I have a course on there called the .NET Developer Toolkit, and there are free modules in that course. It's a full course. It's being built out over time. There's a number of free modules there that you can take. All you have to do is register on the site. That's it, and you will have access to all the free content in the .NET Developer Toolkit. So I go through user secrets and dependency injection and introduction to VS Code. These are all free modules. So go over there, take a look, check it out, and yeah, have a look around at the other things I have on lesjackson.net. But for now, that's all we're going to do by way of user secrets. We will set up the password and user ID as we move through. We are doing everything step by step. I'm just not going to go into too much detail about that. So if you want more information on that, check out bizjackson.net. Enough promoting that. I think we are done with our scaffolding or minimal API. In the next section, what we're going to do is we're going to set up Docker Compose to stand up an instance of SQL Server. So an optional section, if you've already got SQL Server up and running, you can skip ahead. Time codes are in the section below, in the description below, if you want to skip ahead. If you do want to use Docker Compose to run SQL Server, then that's coming up next. All right, so in this section, we're going to set up SQL Server. I'm choosing to set up SQL Server as a Docker container, as it's a nice, quick and easy way to run SQL Server without too much fuss. If you have an existing instance of SQL Server running, feel free to use that. This is just an optional step for those of you that don't have SQL Server and want to get it up and running quickly. So it goes without saying that you'll need Docker installed or Docker Desktop, something like that, installed and running. As I do here, we're using Windows. Docker Desktop's also available for Mac, and I think it's coming out for Linux as well, but if you're using Linux, you can just use regular old Docker. So just to check that you have it installed, if you do docker -- version, you'll get your version back, and if you do docker ps, that will list your running containers. Also, just a quick sidebar, if you're using Visual Studio Code, you can install this Docker plugin that lists all your images and running containers and stuff. I really recommend you do that if you're using VS Code. It's a nice, easy way to manage things. Fantastic. So what we want to do is with Docker running in our project, I'm just going to add a new file to the root called docker-compose.yaml. And YAML, for those of you that don't know, is just a kind of markup syntax using white space. So it's okay, but it can be a little bit fiddly at sometimes. So we're just going to define a Docker Compose file, which means we can easily start and stop a SQL Server container. You can do all this stuff at the command line, but it gets a bit laborious, so putting it into a Docker Compose file just makes it a lot easier to manage. So the first thing we will start with is the version of Docker Compose that we're using, and I think at the time of making this video, the latest version is 3.8, but to be honest with you, it doesn't really have too much of an impact on what we're doing. Next, we'll define the services that we're going to have, and services are basically just, SQL Server in this case. You can have multiple services defined within the one file. We're just having one, in this case, SQL Server. So you give it any name you like. I'm just going to call it SQL Server. And then we specify an image that we want to use. And an image is just the blueprint for where we can get a copy of SQL Server from, basically, or if you were doing Redis or Postgres, the image is just the blueprint of that particular application. And in the first instance, Docker will reach out to Docker Hub to try and get that particular image. So we just want the latest version of SQL Server. So we get that at mcr.microsoft.com/MSSQL server. I need to be really careful with my spelling here. If I get this wrong, it's not going to work, obviously. And then the version we want is 2019 latest. Okay, so if you wanted version 2017 of SQL Server instead, you would specify that. So that's just our image name. And then finally, we just need to set up some environment stuff, which is basically just telling us how to start this particular container. So take that out. And again, one thing that I haven't really mentioned is this indentation is really important. The YAML files are kind of white case sensitive, so make sure you have the file indented exactly as I have here. Now this will be part of the GitHub repository, so you can maybe just copy this file down if you don't want to type it all in yourself. So the first thing we're going to pass in by way of an environment variable is accepting the license agreement. So that's accept_EULA. And then the value we're passing in there is yes, or the value we're setting is yes. And I think I've spelt that wrong, EULA. Okay. The next one is the SA password, which is a system administrator password using SQL Server authentication. And we will just pass that in as a string. Now again, you probably typically wouldn't want to have your passwords in plain text. In fact, we will be using user secrets in our application, but in our Docker file, we just have it set here. So probably don't want to be doing that obviously in production type environments, but for the purposes of this, it's fine. We set it like this. And then the version of SQL Server that we want. And when I say the version, maybe not so much the version, but the family of SQL Server that we want. So by that I mean, do we want the development version, the full version, or what's the other ones? Express. In fact, Express is the version that we are going to be using. So MSSQL_PID, and then the value in this case is Express, which is, of course, is the free version of SQL Server. So we don't really need to pay for it, which is good. And then finally we do, the final thing is the ports that we want to use. And I'm just going to use the same port for our internal to external port mapping, which is, we'll use the default SQL Server port of 1433 and 1433. And that just means we have an ability, if you don't specify that, then you wouldn't be able to access the SQL Server running in the container. This just allows us to do an external to internal port mapping using the same port. I think that's good. If we save that off, that should be all good. I'll just make sure everything's doing one last check. Should be fine. All right, fantastic. Now, as you can probably tell, I'm not going into too much detail about Docker. This isn't a video about Docker, but we'll go through enough for you to start and stop this particular image, which we'll do now actually. So, doing a quick directory listing, make sure you can see the Docker Compose file in your context here, and then you just type docker-compose up to spin it up. And I'm going to use the D flag, which means that we get our command prompt returns us straight back to the command prompt. If you don't put the D flag in, then you'll get a whole host of debug stuff spinning out. And you can see here that our SQL Server is up and running. Now, as I said, over here in the extension, if you do a quick refresh, you'll see that we actually have an instance of our SQL Server up and running. And you can stop it from here as well, if you like. So right click and stop. Again, we can do an up key to run it back up, and you'll see this running back up. Then let's go get started again. You can stop it at the command line. So docker compose stop. That will just stop it here. It should reflect it here in a second. There we go, now it's stopped. All right, so you can do it at the command line, or you can use this tool here. And to be honest with you, for this video, those are the only two commands that we're going to cover, and they're the only ones that you'll need. So let's just make sure it's up and running again. Fantastic. And then just to double check, what we're going to do is I'm going to use Microsoft SQL Server Management Studio, which I'm just starting up. This is a management tool that you can use. It's free and you can download that. I'll put a link in the description below where you can get a copy of this. And it's just a graphical user interface for SQL Server. You can get plugins for Visual Studio Code for SQL Server, so feel free to use that as well if you don't want to install something like Management Studio. And that's just started on my other screen, so I'll just pull over the login. So we are going to be connecting to the database engine. The server name, we're just going to use this local loopback address. We're using SQL Server authentication. The other authentication methods are here if we're using Windows or Active Directory or something, but we're just using SQL Server. We're using the SA password, which is basically this account here and this password here. So if we come back and we just type in that password, you should be able to connect in to our SQL Server. And it's on the other screen here, so let me just make that fit the screen. And you can see we've connected in to our Docker container. We don't have any user-created databases. We have our system-created databases, as you'd expect, but nothing else. So we'll put that to the side for one moment. Again, if you already have SQL Server, then you didn't need to do this. This is just a nice, quick and easy way to get SQL Server up and running. Fantastic. So with that done, next section, we're going to move on and we're going to start creating our models, our data entities that we're going to use within our API. So we'll do that next. All right, so in this section, we are going to create our model that our API is going to work with. So again, just please focus on the minimal API architecture over here. So we're going to build out our model, which is fairly simplistic. And while we're at it, we will build out some DTOs that we will map to our model when we come to that point. But we'll just build out the DTOs ahead of time, and you'll see what they look like when we do them. They're very, very similar to our model, but they're detached, obviously. Fantastic. And again, just a point to note, if you were doing an MVC-based API, you would be doing exactly the same thing. You'd be creating models as well. So there's really no difference between the two approaches here. All right, so back over in our project, into our File Explorer, new folder, and we're going to call it Models. Fantastic, and we're going to create a model, and we're going to call it Command. So new file, and model is going to be command.cs. And again, for those of you who watched any of my other videos, you'll know the kind of example that I like to use. I like to use this example of command line prompts that we store as a library. So, things like Docker and .NET and Kubernetes, they all have command line arguments that I personally don't remember. So my idea is that we can use this API to store a big library of these commands and then retrieve them as and when we want. So it's a kind of nice little realistic sort of use case. So it's not actually that important for the purposes of what we're doing here, but that's kind of what we're doing. We're storing a series of command line prompts along with what platform they belong to and all that kind of stuff. So first thing is namespace, and our namespace is 6 min API .models. Fantastic, and it's a class, public class, and it's just called command. Very simple class. All right, so first property is going to be an integer, and it's going to be an ID, a primary key basically in our database. Our next property is going to be a string, and we'll make it nullable, so that's the question mark there, and we'll just call that how to. There's different ways of, if you actually come back over to our project file, we have this nullable flag enabled. It's kind of a new default setting within .NET 6, so it means that you have to be a bit more prescriptive about whether properties can be nullable or not. And there's various ways that you can define that. So I'm just using this syntax here where I'm saying, yes, this how to attribute can be nullable. That's what the question mark means. There are other ways of defining your properties, but that's just the way I'm doing it here. Next property is going to be, and by the way, if you just type prop as I'm doing there and then tab, that creates your property for you really simply and quickly. It's another string, and it's going to be called platform, which is just going to store the platforms of our associated commands. And I've just realized I have spelled that wrong, so how to. And you'll see this is what I'm talking about here. We're getting a warning. There's nothing wrong with it, it's just warning saying a non-nullable property platform must contain a non-null value. So in order to get rid of that warning, you can just do that, okay? Just to say that it can be nullable. And then our final property is also a string. And we'll make it nullable, and we will call it command line. So again, just to give you go over the use case again, we will store, .NET Run or Docker PS or whatever in here. The platform will be either .NET or Docker or Redis or whatever, and how to is just a little description of what that particular command prompt does. Now before we move on, what I'm going to do is I'm going to decorate each of these properties with some attributes that are going to lend itself to when we taking a look at validation. So you'll remember one of the differences between a minimal API and a controller MVC based API was validation does not come out the box. So I want to put in some attributes here that will demonstrate the lack of validation abilities or features in minimal APIs. So the first thing I do want to do is on our ID property, I'm just going to specify that as a key. That's not so much a validation property, it's just telling our telling Entity Framework Core what it is, but again, it will realize that is what this property is by default. You don't technically need to put this in, but I like to just do it just to make the code a bit more readable. It's complaining, so we need to bring in the namespace, so control and period within the key attribute as it's complaining, so control period, and then it gives you a number of resolutions. So we want to bring in data annotations. Also want to specify that these are required. So this would be, would throw a validation error in an MVC based API. It won't with a minimal API. So I'm going to put it in just to show you, and we can test it out. And just to take it a bit further, I'm going to specify the max length on this. We'll make it incredibly short. Okay, so the idea here is that you should not be able to add a string or pass a string that's more than 5 characters in length for a platform. And again, in an MVC-based API, it would throw back a validation error if you pass more data. With the minimal API, such as this one, well, you'll see what happens. So I think that's good. We'll save that off. That's our model defined. Fairly simple with some sort of validation attributes there. Fantastic. Now, while we're at it, just ahead of time, I want to create our DTOs. Now, as I said, DTOs are external representations of this particular class here, or internal model. So we're going to create 3. We're going to create one for when we pass data back to a client. So we're going to call that a read version of this. So here's data that we pass back when we're reading data. We're going to have a create version. So when we're actually attempting to create a command resource, then we're going to define a DTO that does that. And we're also going to create one for the update operation or the put operation. So there's going to be 3 DTOs. They're all going to be very, very similar, but I'll show you the differences between them as we move through. So right click, new folder. I'm going to call this DTOs. The first one we're going to create is our read DTO, so new file, and we're going to call it command read DTO.cs. And I'm going to cheat a little bit. I'm just going to copy this code here and we'll edit it as necessary. And the point here really is that DTOs are can be very, very similar to the actual model that they are representing. So the namespace is wrong, so we're going to change that to 6minapi.dtos. The class name is wrong, so we're going to call it command read DTO. So the idea is, again, the command read DTO is the data we pass back when we're doing a read operation. So yes, we want to basically pass back all of this stuff here. But because it's a read DTO, I'm not going to bother having any of these attributes in here because we're just reading the data. So there's no real need to validate it or anything like that. So I'm just going to take those out. You can leave them in. They're totally benign if you leave them in, but we'll just take this out for now. So that's our read DTO. And again, the idea would be, say that, looking back at our model, say the platform for some reason was sensitive information and we didn't want to pass that back with our payload. What you would do in the command read DTO is you just take that out. And let's just comment that out. So when somebody does a read request to get command data, they would get ID, how to, and command line, but they wouldn't get platform. That's the kind of idea behind it. But at the moment, we are just passing everything back. Fantastic. So let's go into that. Next one we're going to do is the create DTO. So new file, command create DTO. And this is the version of the model that you will pass when you are creating a command. So command create DTO.cs, not .com. Come back here and copy this again. Copy it and we'll pass it in here. We will change the namespace from models to DTOs. Fantastic. Now, when we are creating a command, we do not need to pass an ID because the ID will get created by our database by default. Okay, and I'll show you that when we come on to migrating our model down to the database, but we don't need to pass an ID. That's auto-generated for us. But regards to everything else, we will pass everything over. Now, I'm going to keep these attributes because they will help us demonstrate this concept of validation. And we will want to pass over all of these attributes when we are creating a command. So we'll save that off like so. I think that's all. Oh, and we need to change the name of it as well. So command create DTO. Save that off. And then finally, right click new file. We're going to do a command update DTO. And I'm sure you can guess that this is the payload that you would pass when you want to update a resource. And again, we are working with minimal APIs, so they will allow you to work with the put-based operation, but patch is not yet supported. And all I'm going to do here is actually going to copy this entire command create DTO code because it's basically exactly the same thing. And I'm just going to change the name to command update DTO. All right, so the idea is when you're updating something, you'll pass this body payload over, this model over in the body text. Now you might be going, where's the ID? Shouldn't you be passing an ID? Well, you could actually put the ID in here if you wanted to do that, but the way we're going to design this is we're going to pass the ID of the resource, the command that you want to update, we're going to pass that in the route, the URL basically. So that's where our ID is going to come from. So just to deduplicate passing in IDs in two places, we're only passing it in the route, and so we'll take it out of the object here, or the class here. Fantastic. So that's our model done. That's our DTOs done. If you don't quite get the DTO stuff, don't worry. We're going to work with mapping a bit later on. We'll map together the model and the DTOs, and when you see it running, it will make a lot more sense, but it just gets those out the way for the moment. Fantastic. So the next thing we're going to do, the next section we're going to do is we're going to start or create our DB context so that we can actually migrate, if you like, our model down to our persistence layer, our SQL Server that we just set up. So we'll do that in the next section. All right, so in this section, we're going to move on to our DB context. So let's just do a bit of a progress check on where we're at. So we've just done our model. Again, we're just doing the minimal stuff at the moment. We've done our model, we've done our DTOs, so we're going to move on to our DB context down here. All right. So back over in our project, let's just minimize these folders here. We're going to create another folder, and I'm just going to call this folder data for our data layer. And then into that folder, we're going to create our DB context. So new file, and I'm just going to call it app.dbcontext.cs. All right, so we'll start with a namespace to begin with, and it's 6min API, but this time we're in data. And it's a public class called app.dbcontext that implements something called dbcontext. That's going to complain, so we'll do a control period, and we'll bring in using Microsoft Entity Framework Core. Fantastic, and we'll put some curly brackets there. If we just do CTOR to do a constructor, public app.dbcontext, into there we're going to expect DB context options of type app.dbcontext, and we'll call that options, and then we'll just specify that base parameter with options as well. Fantastic. All right. And then the only other thing we need to specify is something called a DB set, which effectively represents, in this case, our model, our commands model, and that will be propagated down to our database via a migration, which you will see in a minute. So we will just specify a property, so prop tab. Instead of it being an int, it's a DB set of type command, and we're going to call that commands, and we're going to say that we'll set that as type command, which will be complaining because we don't know what that is just yet, but we'll bring in that namespace, that space here. So control period to bring in 6min API models, and that should resolve. Okay, so that's just basically we're creating a property of type commands, and we're calling it commands. So we'll save that off. So that's our DB context class defined. Let me just close these things down here. And we'll come back into our program class because we need to kind of register our DB context over here in our program class. Now, in order to register our DB context, we will use dependency injection to do that. Again, I'm not going to go into how dependency injection, what that is and how it works in any great detail in this video. Again, the .NET Developer Toolkit course on resjackson.net has a whole free module on dependency injection if you want to really delve into the detail. But of course, we'll do everything here step by step, but I'm not going to go into massive amounts of detail. So we do want to register this class for the dependency injection so we can make it available to the rest of our application. In order to do that though, one of the key things we need to pass when we're registering our DB context is a connection string to where the DB context can reach out and talk to our SQL Server. So in order to do that, what I want to do is in our app settings development JSON file, I'm going to create a base connection string that has some parameters in there. And then I'm going to use user secrets to fill in the rest of the blanks with regards the user ID and the password. So some of the config is going to be public, put it in our app settings development JSON file, and some of the config is going to be in user secrets. So over in app settings development JSON, if you put a comma here, take a new line and we'll specify an attribute called connection strings. You can see it's already a out-the-box parameter, and then you can specify any number of connection strings here that you like. So I'm just going to call this SQL DB connection, and then I'm going to give it the values of server equals localhost, which is our Docker instance in this case, comma port 1433, and then the next bit of config is the initial catalog or the initial database. So initial cat log equals, and we'll just call this command DB. Now you could continue along here and you could put user ID equals SA and password equals whatever. I want to not do that. I want to just keep this somewhat, we'll say somewhat anonymous or benign by just having these particular details here. So what we're wanting to do then is configuring our username and password somewhere else, in this case in user secrets, and then we will build our connection string to include those elements and this element, so we have a full connection string. So that's part one of our config, the kind of base location and the base or the initial catalog name. So we'll save that off. Coming back over here to our CS proj file, just to remind you, we generated or initialized our user secrets. So we have this GUID, which means that we have a location now where we can uniquely store our user secrets for anything we want, really. So first user secret we're going to create is for a user ID. So it's .NET user secrets set, and the first attribute we're going to set is the user ID, and we'll just call that user ID, and then the value is just SA. All right, so .NET user-secrets set, the key is user ID and the value is SA. Okay, and that's been saved away to our secret store. Just do an up key, and we'll do one for password as well. And we'll make sure, in fact what I'll do is I'll just copy and paste it from here. Okay, copy, and we'll paste it, paste that in here as well. Okay, cool, so we have two bits of config now stored away as user secrets, one called user ID, one called password. Fantastic. So back over in our program class, what we want to do now is construct our SQL Server connection string, and then we can pass that or use that with our DB context. So up here, after the Swagger gen stuff, if we just create a variable called SQL connection builder, we're going to build up. That wasn't even remotely correct, was it? Con builder. We'll make that equal to a new SQL Server connection string builder. SQL connection string builder, let's make the U lowercase, and we'll probably need to bring in Microsoft Data SQL client. Okay, and we're going to build up our SQL connection string. So SQL con builder, connection string equals builder, configuration, so we're going to access our configuration layer, and the first thing we're going to do is we're going to get the connection string from our app settings JSON file. So we want to pass in here the name of our connection string. So back over here, we use this connection strings property, which allows us to use get connection strings from our configuration object, and all we need to pass in is the name of the connection string. So that's basically passing in the base connection string, if you like. Not enough to connect us to our SQL Server though. We need to pull in our other bits of config. So we will say SQL con builder, and this time we will say the user ID property on that is going to be equal to builder, configuration object, and this time we just specify the user ID, which in this case is this parameter here. Let's copy that, paste that in here. So you can see what we're doing here. We're building up our connection string using the attributes that we've saved away. And the great thing, as you can see here with .NET configuration, is it doesn't matter where your configuration is stored. This bit of configuration is stored in a file. This bit of configuration is stored in user secrets, but you access it in pretty much exactly the same way. It's very cool. And then the last thing we want to set is the password. And I'm just going to copy this line here to save me typing. It's winter here now. We're getting into winter in Melbourne, so my fingers are pretty cold and not typing very well at the moment. So our SQL con builder now should have our complete connection string that's valid and allows us to connect to our SQL Server. So the last thing we want to do then is just register our app, our DB context. So builder, services, add DB context of type app DB context. And we'll bring in the namespace, which is using 6min API data. And then using a lambda expression, we will get and pass through our connection string that we've just created. So we want to tell it that we're using SQL Server, which probably requires another namespace. Yeah, it does, using Microsoft Entity Framework Core. And into that, we just pass our connection string, which is just this thing here, SQL con builder connection string. All right, okay. So just a quick recap, we placed a part of our connection string in our app settings JSON file for our development environment. We stored our password and our user ID and user secrets, and then we constructed a full connection string using this methodology here. And then finally, we registered our DB context for dependency injection and passed in this connection string. So that should all be ready for us to be able to use. So in the next section, we'll take a quick pause here. In the next section, we will migrate our model down to our database, and we'll find out whether all this stuff worked. So we'll do that next. All right, so let's just do a quick status check of where we're at. So we have created our model, we have created our DTOs, although we've yet to do a mapping between them, but nonetheless, our DTO classes are there. And we've just created in the last section our DB context along with all the config needed to connect us through to our database server. So we have our database server up and running now. What we don't have is a database. So we've got our database server. We don't have a database that represents and contains our data. And so what we want to do now is migrate our models down to our database, and models will be represented as tables in our database. So that's the step that we're going to do now. Fantastic. So just coming back to our app settings development JSON file, we set this initial catalog attribute here and we gave it a name of command DB. So that's going to be eventually the name of our database. And I'm just noticing here, I put a colon in here. That is wrong. It should be a semicolon to separate our elements. So this one here, which is the location of our server, is one attribute, and then this second one is our initial catalog. So that should be a semicolon, not a colon. So just make sure you change that. All right, fantastic. And we'll make sure we save off our program file as well. But all we really need to do to generate migrations and create a database effectively is run some stuff at the command prompt. So I'm going to clear the screen, and it's .NET, and then we're using the command .NET EF for Entity Framework, and we're wanting to generate some new migrations. So we're going to say migrations, make sure it's pluralized, add, and then we just give our migration a name, init. initial migration. Should we just call it, yeah, migration. It's kind of obvious it's a migration, but we'll call it initial migration. So .NET EF migrations add initial migration. Now, if you get an error around something of the nature of we don't know what EF command is, then you'll have to install the Entity Framework tools, and I'll put a command that you need to type to install that. But that all looks pretty good. What you'll see happen by typing that was a migrations folder was created, and inside of here we have our migrations. So if we take a quick look at this, you can see what it's actually going to do, and I think it's this file here we actually want. So if you take a look at that, you can see that there's a create table command. It's going to call the table commands, and then it's going to create our columns in our database and all that kind of good stuff. And then there's an up method, which is for creation, and then there's a down method, so you can roll back migration. So that's all done for us automatically. At this point though, our database has not been created. All that's happened by running that command is that migrations have been created. If we come back over to our SQL Server instance and we do a refresh, still nothing there. It's just purely migration files have been created within our project. So to migrate down, and this is really where our config will be tested out, it will attempt to connect to the database and actually push that migration down. So again, .NET EF database update. And that looks pretty good. So we didn't get any errors, looks all good, looks like it pushed that down. So if we do a refresh here now, you'll see we have a database called CommandDB. And again, just to labour the point, back over in App Settings Development JSON, this is the name of the database that we wanted to create, CommandDB, which is what we now have. And then under here, under tables, we should have one table called commands. And if we expand that and expand columns, you'll see we have all the columns that we expected. So we have ID as a primary key, which is auto-incrementing. So again, whenever you insert a value into this table, you get an ID automatically generated. And then we have our other columns. And you also see here for platform, it's an nvarchar of 5, which we had specified as one of the attributes on the model. And you can see that they're all not null. They're all required attributes, which again, completely maps what our model was specifying. Fantastic, so that's all very good, that's all positive, it all worked. And I mean, if you get any errors there, just go back and make sure you typed in everything correctly and there are no syntax errors. But if you followed along, you should have no issues. Cool, so that's basically our kind of data layer setup. What we're going to do next is set up a repository class, which is this kind of, a layer of abstraction above what we've just done. Okay, so we'll do that next. So yes, in this section we're going to set up our repository and we're going to create our repository artifacts in the data folder. So the first thing I'm going to create is our interface specification. So new file, I, command repo.cs. And again, we're going to be using dependency injection here. So the way we're going to create a repository is to define our interface, which is just a series of method signatures as to what methods this interface can provide to a consumer. And then we're going to actually implement a concrete implementation of this interface as well in a separate file. And then we will use dependency injection to register both the interface and the concrete implementation class. Again, if you want more detail on dependency injection, check out lesjackson.net and my free module on dependency injection. All right, but let's get back to this and let's define our interface. So we will start with our namespace, which is 6min.api.data, and it's a public interface called I command repo. Fantastic. And we're going to have a number of method signatures that this interface is going to provide to our consumers. Now I'm going to make these asynchronous methods, so with that in mind, we're going to be specifying a task return type. So the first one, first method we're going to specify is save changes. And with Entity Framework Core, whenever you make a change to via your DB context, so for example, when you add a resource, just adding it is not enough to persist it down to the database. You have to then save the changes. So it's basically a two-step process. You add something or delete something or update it. You have to then save the changes to your DB context, and that sort of flushes the changes down to the persistence layer. So the save changes method, sometimes people forget it. It's very important, critical. So that's our first one. And again, you'll see here, it's just a method signature. There's no implementation. We're going to do our implementation in the next step, which is our concrete implementation class. And then we're just going to have some methods, one for creation, two for reading, and one for deletion. We don't actually really need one for updating, and I'll go over why we don't need that a bit later. So the first one we'll do, again, it's going to be an asynchronous method. So we'll say task, and this time we're going to just say we want to return one command. So we pass in an ID in the route, and we get one resource back. So we just want one command back. I'm going to make this nullable, and we're going to say get command by ID, and that will expect an integer called ID. And we just need to bring in the namespace for command. Try that one more time using 6 API min models. We're going to have one other read command, which is just basically getting all of our commands. So again, still a task because it's going to be an asynchronous method. But this time we're returning an I enumeration of command objects. And we'll call that get all commands. We don't expect anything in there. And it looks like we have to bring in the namespace for that. I think I've probably spelt it wrong if it's not recognizing it. Enumeration looks okay. Not enumeration, enumerable. Should have known that. There we go. How long have I been doing this and I got that wrong? Oh my goodness. Right, so that's our two read methods, getting an individual resource, getting all the resources. Next one we're going to do, is creating. So we'll say task create command, and we will just expect that to accept a command object. Such as that. And then the last one is not going to be an asynchronous method, so we'll just say it's going to be void, and we'll call that delete command, and we will expect a command of command. And sort of obviously, or maybe not obviously, we are not doing one for update. The reason for that is we don't actually need one for update using Entity Framework. We will just do the update directly on the DB context, and all we actually need then is save changes. If that doesn't make sense, don't worry. When we come on to doing it, you will see how that manifests. And again, yes, these are all asynchronous because we have asynchronous methods to allow us to do things like reading and creation. There isn't an asynchronous delete command on our context. And again, you'll see what I mean by that when we come on to doing that. So let's save that off. So again, this is just our interface. It's not implementing anything. We want to now implement it. And I have just realized I have not capitalized that. So let's just make sure we capitalize that. Otherwise it could cause us issues going forward. Fantastic. So now we're going to implement this. So we're going to create a class that can implement this. So right click data, new file, and we're just going to call it command repo. So no I, CS. Namespace again, 6 min API, bring data. It's a public class called command repo. And we are going to implement our I command repo. Okay, so we want to implement it. It's erroring out because we haven't implemented any of the methods that we have specified here. So in order to do that, we can simply put our cursor in the complaining artifact. It stopped complaining for some reason, I don't know why. But let's give it a go anyway. Control period, no code actions available. Maybe if I save it, that should force it. There we go. We want it to complain. So we do control period, and that will give us this implement interface option. And it just implements some placeholders for us with a throw not implemented exception. So I'm going to minimize our, forgot what that was called, our terminal window there. And I'm just going to move through each of these in turn. So let's maybe start with save changes, as it's probably the simplest one to do. And actually, before we do that, let me just unmark that. We actually need to get access to our DB context in our implementation class, because ultimately that's what we're working with. So again, let's come back to our diagram or architecture. I just want to kind of explain this a wee bit in case you're getting a wee bit lost. Let me just find the right one. So basically what we're doing is we're building out a repository, okay? And our repository actually needs to make use of our DB context, okay? It actually needs to use our DB context. So we need some way of getting access to that. And the way we do that is through constructor dependency injection. We're going to inject our DB context into this class via its constructor. So before we do any of these methods, I was getting a little bit ahead of myself there. What we want to do is create a constructor. So CTOR, tab again, and we are going to expect, we're going to expect a DB context to be injected in. So it's going to be an app DB context called context. And we will just assign it to a private read-only field. So underscore context equals context. Again, there is a full module on dependency injection on lesjackson.net. And we just need to make sure this underscore context is defined as a read-only field. Okay, so just quick recap. Over here, we registered our DB context here in our services collection here using this command. So that means that it is available to us to inject into our constructor here. Okay, and then all we're doing here is just assigning it to this private read-only field called context. All right, so coming back to here, what I was going to do originally, we want to just use our context to save our changes. And it's pretty easy. You just use context and then save changes async. Now we're going to get some complaints here. Don't worry about that. First complaint we're getting is it's saying that not all code paths return values, so that's okay. We can fix that out by putting an await statement in here. Okay, and this is going to complain now by saying the await operator can only be used in an async method, and that is absolutely correct. So we just have to add async in here, and that should resolve our issues. So basically, anything with a task really needs the async keyword. I'll just put these in to stop it further complaining, and it's going to now complain in another way by saying that we don't actually have any asynchronous methods in here. The async method lacks an await operator, so it's kind of chicken and egg. You know, you need both await and async. These would just work synchronously if you don't have any synchronous methods in there. All right, so let's do a slightly simpler one. Let's do our get all command. So this is, we are just returning all our commands that happen to be in our database via a DB context. So we're going to do return await. Again, that's our await keyword, and we're going to use our context, and we're just going to use our commands collection, and we're just going to return it to a list. Async actually, so we want to make it an asynchronous, so to list async. Okay, I think we need to bring in link async. Okay, so it wasn't in a list of available commands or options, methods, should I say. Control period. It wasn't link, it was using Microsoft Entity Framework core, so we needed to bring that in. All right, now I think we can actually get rid of this because of the way I defined my, the way I defined the DB context. We don't even need to put that in now. Let's do the next one, which is just getting an individual resource. So let's do return await context commands, very similar to the one above, but this time we're going to use the first or default async method and the lambda expression in there. C goes to C where ID equals the ID that's passed in. All right, so hopefully, and I need to make sure that's a double equal sign. Okay, so basically you're getting an ID passed in here. We're going back to our DB context and we're using first or default, and we're just using the ID to return the first or default member. Fantastic. And then up here we have got create command, so let's do that. So the first thing we actually want to check, we want to see if the command object that's been passed in is null. And if it is, then we're not even going to attempt to add it. So we'll just throw a new argument, null exception, name of command. Right, so it makes sense. We don't want to start adding stuff that's nullable. And then if it's successful, we will await on our context again, assuming I can spell it correctly, and we are going to use add async. There we go. And what are we adding? We're simply adding a command. There we go. And what you can see here is now we've got await statements in our methods here. The warning signs have gone. So we've got an asynchronous method within a paired await keyword. All right, fantastic. So the only other thing we've got to do is our delete method. So it's pretty simple. Again, we'll just check if our command object is null or not. And if it is, then we will just, again, we'll throw one of these new argument null exceptions, the name of command. Fantastic. And assuming we do have one, then all we're going to do is context commands, remove command. And that's all our methods implemented, I think. So let's just save that off. So let's just get our command prompt back up, and I just like to do a .NET build just to make sure everything's okay. And it looks pretty good. Now, the other thing I need to do, which I'm forgetting, is we need to register our interface and our concrete class in our dependency injection container. And let's just do that after our DB context. So I'll do a Control B to get rid of our Explorer at the side there, just so we have a bit more room. Go to the end of the line and we'll use our builder collection, services, and we're going to add a scoped. Again, I'll say this again, don't want to keep saying it, but if you're wondering what's add scoped and all that stuff, check out my free module. Keep saying it on lesjackson.net, but seriously, I think it's a really good module. Fully goes through dependency injection, goes through all this stuff. But basically, a scoped refers to the lifetime of these objects, how long they last for, basically. All right, so the first thing we want to specify is our interface. So I command repo, and then we specify our concrete class, command repo. There we go. And really all that's saying is whenever we get asked for this, we're going to give them an instance of this. That's basically all this is doing. So it's just registering in our dependency injection container. And it means that we can then swap this out, this concrete implementation, we can swap that out for something else. So this is really why I like using repositories, because say we're no longer using SQL Server and we're going to use some other database platform. Let's say Redis, for example, that doesn't really have a connector for, doesn't really work with Entity Framework Core, so we don't have a DB context. We have to get rid of our DB context, we have to rewrite all our other stuff, but the repository would stay exactly the same, or the interface to the repository would stay exactly the same, and all we'd have to do is build a new implementation class and just swap it out. So it means that any consumers of our interface, which we will be doing in a minute, are blind or oblivious to the changes, the persistence changes. They're ignorant, persistence ignorant, they're ignorant of the persistence layer, and that's why I like using a repository. Whereas if you use a DB context directly, if you decided to go with something like Redis, which won't work with a DB context, you'd have to switch that out, and then you have to rewrite code in all your other parts of your application. So I do like the repository pattern. All right, so let's save that off. All right, so that is our repository done. Next, what we're going to do is we're basically doing all the groundwork. We've not really come to the main event, which is the endpoints that we're going to define in our API. And in fact, everything we've done to date is exactly the same as we would have done in an MVC-based API, okay? Exactly the same to this point. And in fact, the next step that we're going to do, again, more groundwork, is just wire up Automapper, and we're going to create some profiles, or a profile, that will allow us to map our DTOs to our models and vice versa. So we'll do that in the next section. All right, so in this section, we're going to set up Automapper. And what is Automapper? Well, it's a library that allows us to map from one object source to an object target. So because we are using models and DTOs, we want a nice, simple, effective way of mapping from one to the other. So to put it in context, think about the scenario where you are calling an API endpoint to return data. We have said that we want to return the read DTO to the consumer. So we want to return the read DTO, but ultimately the source of that data is coming from our database, from our DB context, from a repository, which are using models. So we need to map our source of the data, which in this case is our model class, and map it through to our DTO class. So the source is model, command model, and the target is read DTO. Flipping on its head, when we are creating resources, we are going to be passing as a source, an input, command create DTO, and that ultimately is going to get put into the database as a model, a command model. So the mapping in that case is a command create DTO is the source, and the model is our target. So using Automapper, you can do that really easily. And because we've named the properties in both our DTOs and models exactly the same, Automapper just works pretty much out the box really easily. All we have to do is express the mappings that we want. And that's all we're going to do today. It can get a lot more interesting and a lot more complex than that, but we don't need to worry about that today. So back in our project, let's get my File Explorer up. I'm going to create a new folder called Profiles. And into Profiles, we're going to create a new file called Commands Profile.cs. And we'll do a namespace as usual. 6main API dot profiles. And it's just a public class called commands profile. And it's going to implement a class called profile, which is from Automapper, so control period to bring in Automapper. And again, just to, I think we've said this already, we've already brought in Automapper over here. Fantastic. So then all we need to do is just define the class constructor, so CTOR, tab, no parameters, and it's in our class constructor that we define our mappings that I was talking about. So just to give us a bit of help, the syntax kind of goes source to target. So we do it through something called create map. We specify the source. So let's think about our reading scenario. The source is our model, our command model. That's our source. Our target is our command read DTO. So source is command, and targets is command read DTO. Okay, we just need to bring in the namespaces for DTOs and for models as such. Okay, so that's taking care of our read situation. Our creating situation, our creating scenario is kind of flipping it on its head. So our sources are DTO, or command create DTO, and ultimately that's going to get targeted to a command. Fantastic. And then the last one is for our update scenario. So create map. And our source is a command update DTO, and it's going to command. So it's very similar to the create method. So let's save that off. And then the only other thing we need to do with regards to Automapper is we need to register Automapper for dependency injection, like we've done with a lot of our other stuff. So over our program class, after our registration for a repository, we just use our builder, services collection, and then we're going to say add, and there should be one for Automapper in here. They are, add Automapper, and then all we need to say in here is app domain, current domain, and get assemblies. And that should, don't forget to put the round brackets. So again, that's just registering Automapper for dependency injection so we can use it throughout the rest of our application, and you'll see how that manifests in the next section. So that's basically all our groundwork done. I think I may have already mentioned this, but what we've done so far is exactly the same as you would do for an MVC based application. We're doing exactly the same thing from a minimal API perspective. Okay, so it's exactly the same as the MVC API is what we've done here in the minimal API. Now, just before we go on, I mean, I did mention at the top of the video that the whole point of minimal APIs is they have lower dependencies and lower code, and you might be going, well, hang on, there's loads of code here, and you're saying it's exactly the same as the MVC app. Why do all this? Well, it's actually a valid point. You don't need to use Automapper. You don't need to use repositories. You don't need to use DTOs. You could, if you really wanted to keep your minimal API super minimal, not use any of that stuff. I just don't think it'd be a very good API. But the same token is also true of MVC apps. You don't need to use repositories with MVC APIs or DTOs or anything like that. So what goes for one goes for the other. So I think that argument's somewhat nullified because it really depends on how you want to write your APIs fundamentally. So what's true of one at this point is true of the other. What we're coming on to next though is really the bang for your buck of this video, is where we're going to define our API endpoints. This is where it diverges and becomes different, whether you're looking at an MVC API or in this case a minimal API. So we're going to do that in the next section. We're going to set up our endpoints. All right, so I did just say we're going to come on and start adding some endpoints to our minimal API, but just before we do that, I thought it might be useful just to do a quick refresher on having a look at a controller-based API, an MVC API, where we're using a controller. So as I've said quite a lot now, our minimal API does not use a controller, and we use some other methodology to create our endpoints. But looking at what we have on screen here, this is our equivalent, or MVC equivalent API that I've already written. The code's on GitHub. We're not going to go through that, writing that step by step, but we're going to go through it and do a bit of a review of a controller-based API. All the other stuff we've done so far, the models, the DTOs, the profiles, all exactly the same. But this is where it gets different. This is where the two diverge. So over here we have a controller called commands controller. It's going to work with all our commands. It inherits from a class called controller base, and more importantly, or as importantly, it uses this API controller attribute. It's decorated with that, and it's this attribute that gives us a lot of our out-the-box behaviors and features with MVC APIs. So things like validation and binding and all that kind of stuff, you get it because it's decorated with this attribute. The other thing of note is the route to this controller. So this whole controller has a base route, which is this thing here. So we can find the controller at API v1, and then the square brackets just basically say we want this part of the controller name, so commands. So the actual route, so the base route of this controller is API v1 commands. And in fact, we could actually have used that. So rather than using these square brackets, we could have just typed commands. It's up to you how you want to do it. I'll take that out. I'm going to ignore the filtering stuff just now. We will cover that when we go on to having a look at the real differences between the two, but maybe just stick a pin in that for now. Next thing of note is that, yes, it's just a class. It has a constructor, and it uses constructor dependency injection to get itself a copy of our repo, an instance of our repo, and also an instance of Automapper, because it makes use of both of those things. And then for the rest of it, it's just a bunch of actions that are all decorated with a verb. So this is a get action, as is this one. This is a post. And you can see here we have these methods that basically are our endpoints for our API. So if we look at a simple one, let's take a look at this one here. I'm not going to go through them all. This one here is a GET request. It's expecting an ID parameter somewhere. Forget the name for the moment, but yeah, we're just giving it a name as well. And then the method signature is expecting to return back a single command read DTO as an action result. Okay, and it's an asynchronous method, so we're actually using async task, but that's not that important. And then the name of the method, and we're expecting as an input the ID of the command that we want to return back. And that's where we get some magical mapping happening, where the ID passed in this case in the route, is mapped through to this value here. Then inside the action, we're actually going to do some very similar stuff in our minimal API, but we first use our repository to get to see if there is in fact a command with that ID. Could be null or not. So we put it into this variable here. If it's not null, then it means we had a match. If it is null, then we just return a not found. But assuming we do have something, then this is where Automapper comes into play. What Automapper is saying here is that we want to map the source, in this case our model that we've returned from a repository, and map it through to a command read DTO. So again, that's what we've gone through in the last section, and then we return an OK. All right, so we've got different ones for posting and in this case patch, and we'll talk about patch in a bit more detail later. We have put and delete. Okay, so we're going to basically build the equivalent of this out in our minimal API. So we will actually definitely do that next. All right, so we're coming on to some really interesting stuff now, and that is to build out our API endpoints in our API. So for the moment, if I just get rid of all this other stuff, if I just get rid of the command and I get rid of the Explorer bar, all this code pretty much is just setup code. It's not really functional in any way. So coming on to setting up our endpoints now. So we don't have a controller obviously, so how do we define our endpoints? Well, quite simply, we just define them off of this web application that's been set up and built here. So use app, and then we can use any one of these map commands. So map get for get requests, map post for post requests, and so on. So why don't we do our two read operations or two get operations, and the first one we'll do is retrieving all of our commands from our repository. So for that we want to use map get, round brackets, and then we want to pass in what is called a, I'm just wondering why I'm not getting the IntelliSense stuff. Let's try that again. There, that's better. Just wanted to show you. First thing we're wanting to pass in is something called a pattern, which is basically just our route, effectively. So it can be anything you like, but I'm just going to follow the convention I have been following. So API v1. v1, in case you're interested, just refers to the version of this API. So you might see v2. You might even see latest being used as opposed to an actual version. It doesn't really mean anything in the context of this video, I'm just using it. And then of course we want all our commands. Now again, could be anything, it doesn't have to be that, but in order for it to make sense to us as a REST API, I think we use this format here. Next thing we specify is a request delegate. Now it's actually this request delegate that we pass in our dependencies. So in the controller-based example, controller's a class, constructor dependency has a constructor, and then we use constructor dependency injection to inject in our repository and our mapper. In this setup, we don't have that, so we inject our dependencies in through our request delegate. So we'll specify it as being async, and then we put in our dependencies. So the first one we'll put in is an I command repo. So we're asking our dependency injection container for an I command repo, and we'll get given our concrete class that we registered up here, command repo, but we'll call that repo. All right. And then the next thing we want is to use Automapper, so we'll ask for an instance of IMapper, and we'll just call that mapper. Okay. And this will probably complain because I don't think we'll have the namespace for Automapper. So control period to bring in Automapper. And then we want to define the body of our method effectively. So kind of lambda. And then in here we can write what we want this endpoint to actually do. Now it's complaining here, or warning us, not complaining, it's warning us saying there's no await method inside our method effectively, but we'll change that very soon. In fact, we'll change it now. So the first thing I want to do is get a collection of any command objects from our database that we may have. So var commands equals await on our repo, and we will use the get all commands method. Okay, so just a quick recap. We are using dependency injection in our request delegate to get a repo, which is actually one of these here. And then we are awaiting on it as it's async, and we're getting all the commands and putting it into this variable here. And we now want to return back our DTOs, and this is where we use Automapper. So next line, we are going to return, make use of this new results object. I believe this is new in .NET 6, and we want an OK. We'll return an OK whatever. So even if there's nothing, and in fact we will get nothing because there's no objects in our database, we're always returning an OK. So there's no need to return anything else here. So we'll return an OK, and we'll make use of mapper using our mapper object, and we'll use map. What are we mapping to? So we want to map to an I enumerable collection of what? Of command read DTOs. Okay, that's what we want to pass back. And what is the source? The source is our commands here. So assuming I've typed everything correctly, we probably need to bring in the namespace for this using 6-min API DTOs. That's correct. And that should be good. Okay, so hopefully fairly straightforward, relatively straightforward. And as you can see straight away, much less code already than using a controller, and arguably much more readable as well. Fantastic. So let's save that off. Let's bring up my command prompt. Let's do a .NET run. Awesome. I will get my HTTPS URL, I'll copy that, and I'll bring over Insomnia onto the screen here. Okay, and let's create a new request. So new request, get all commands, and again, this is just a label. It can be absolutely anything you want, but that makes sense to me. And we'll paste in our base URL, API, v1, commands, and then we'll send that off. What do we get? Excellent. We get 200 OK, and we just get an empty array of objects because, well, there are no objects there. So maybe just to test to make sure that that's working okay, let's manually put a command into our database. So we'll use Microsoft, well, you can use anything you like, but we'll use the management tool to do that. Let's bring that onto the screen here, and we'll go into databases, into commands DB, and we'll just do right click, new query. Now you don't need to do this, I'm just doing this just to sort of show you that we can do it this way. Actually, let's do it another way. I'm going to be lazy and go back to tables, and then right click tables and just do edit top 200 rows. Saves me writing an insert statement. So we'll say how to run a .NET app. Platform is .NET, and the command line is .NET run. And if you take a new line, you'll see that we automatically get an ID. Okay, so just injecting it straight into the database, the way it's set up, we get an ID. So that's all good. What I might do is right click, new query, and just do a quick select, just to be double sure that we did actually put something in. So we select everything from our commands table, and indeed we have something there. So that's cool. So if we run this again now, we should get that object back. And indeed we do. Okay, so we get an ID, how to, platform, command line. And just to, let me just stop this from running. Bring up our Explorer. Just to show you, again, just to kind of really be clear about what DTOs are doing, we are bringing back all of those. So here you can see, yeah, we've got all these attributes. If we didn't want the ID returned for some reason, let's comment that out, save it, and we'll run this up again. And then we'll use Insomnia to call it again. Exact same call. We just get the attributes that we want back, but our model remains unchanged. So that is the beauty of DTOs. You can change things, and you can even add things in and all that kind of crazy stuff. So that's the power of DTOs. That's why you should definitely use them. Decouples your internal models from your external contract. Fantastic. So we'll take a quick pause there. Actually, before we do that, I'll just put this back. Not sure we'll need it, but I'll put it back anyway. So we'll take a quick pause here, and then we'll move on to doing our next get request, which is getting a specific resource from our API. So we'll do that next. All right, we're back. So let's just kill that. Let's stop our app from running and do a control backtick to get rid of our terminal, and we'll do a control B to get rid of our Explorer bar. So let's continue on, and let's do our next endpoint, which again is also a map get. This one is a little more interesting though. We'll put in the same route, but for those of you who've maybe done any of this stuff before, you'll know that you cannot have two get endpoints with the exact same route in an API, because there's no way to know which one you want when you call it. So this would actually throw an error if we left it like that. But of course, we're not going to do that. What we're actually going to do is we're going to allow it to take an ID attribute, and we'll call that ID. So this is where we're starting to talk about model binding, okay? And so model binding is absolutely supported in minimal APIs. It's just when you come on to doing what's called custom model binding, that's not really supported. But we'll talk a bit about that later. This is just straightforward model binding stuff. So in our route, we're going to expect an ID. All right, and as before, we'll expect a request delegate, and in fact, I'm just going to copy this. Hopefully you don't think I'm being too lazy. I mean, I could type it, I guess, but let's just do that because we know it's correct. But in addition to passing in our repo and passing in our mapper, we're also going to expect an integer, which we'll call ID. And again, this is smart enough to know that anything passed through here will actually get mapped to this. Now you can use these from statements to actually specify where you want this ID, this mapping ID, to be mapped from. So we could say something like from route, and I think we probably need to bring in namespace here. There we go. So you can actually still do that here, but interestingly, you'll note that it's actually bringing in the MVC namespace, which I said we can't use, but for this stuff, you can actually still specify it. So you can actually say, I want this ID to come from the route, which is what it's doing anyway by default. So I'm just going to take that out. I just wanted to point that out, and we'll delve into that maybe a bit more when we do custom object binding, custom model binding, excuse me. So that's cool. So we will get our ID from here and it'll get passed into our method, and then all we want to then do is just finish our method off. Don't forget the round bracket and the semicolon. Very similar to what we have done before. So we're going to create a command object to hold a command from our repository. And we'll just make that equal to await on our repo. And this time we want to get command by ID, and we'll pass in the ID. Now, there's a chance in this instance that that will return nothing. If we pass in some random number like 23, we don't have an ID of 23, we should return back a not found. It's not like the first one, we were always going to return an OK. So let's deal with that. Actually, let's deal with the opposite case. So let's say we do get a match. So if you say command is not null, so we get a match, we get a hit, then what we want to do is we want to return results, OK again, and we're going to do something very, very similar to what we did here. In fact, I'm just going to copy this and I'm going to change it slightly, because we're not dealing with an enumeration, we're dealing simply with a command read DTO. So we just want a single command read DTO, and the source this time is our command. Okay, but it's the same principle. You're mapping source to target, and that is effectively it. It's pretty straightforward. And then assuming that command is null, then we will return a results not found. Okay, now I do appreciate that you don't need to have curly brackets here as it's just one line after the if statement. I still like curly brackets, but if you wanted to really minimize it down, you can take those out if you wanted to do that. That's cool. Let's run it. Let's give it a go. .NET run. And we know that we have at least one item in there, so let's go and try and retrieve it. So back over here, let's run this one again. It should return back our ID as I put that back in. Let's duplicate this command. So you can just right click, duplicate. And I'm going to rename it and say get single command. All right. And then we'll just add into the route /1, and that should bring back our object, which indeed it does. If you put something in, an ID that doesn't exist, we'll get a not found. Okay, so nice and easy, nice and simple, all working very well. So that's two of our actions done. We'll do a quick pause and then we'll move on to something a bit more interesting, which is creating resources using post command. So we'll do that next. Okay, back in our project. Stop this from running. Now again, I'm stopping this from running. You could use something like .NET watch, which was a new command issued with .NET 6, which kind of allows you to do hot reload. You can see there, hot reload with a little fire. I did open up the Swagger document on my other screen there, just in case you're interested. And theoretically, I think you should be able to, well, let's give it a go. You should be able to add in our new endpoint without actually reloading it. I found in playing with hot reload, it kind of sometimes does what you want it to do, sometimes it doesn't quite, depends what you're doing. So I've had mixed results with it, but let's give it a go. So we've got an application running, just to prove the point. Let's come back to Insomnia and let's just run this again, make sure we get a result. Send, we do, cool, fantastic. So that's running. So let's edit our code with this running. All right, so this time it's app. We're going to map it to a post this time, and we're posting data to it. And again, we're going to supply our route. So let's just copy this here like that, paste that in here. And again, there's no ID component in our post request. We're just creating a new item. We don't have an ID yet, and the ID will get created by our database. So that is sufficient for the moment. And then as before, we'll add our request delegate. And again, I'm probably just going to copy this from here. Being super lazy, but again, it means that you guys don't have to watch me typing, which I think is probably good for you. Let's just finish that off and close that out as such. Now, what we do actually want to do in here, we are not expecting an ID being passed in our route, but we are expecting a request body to get passed in the body. So we do need to add something else into here, into our request delegate. So again, object mapping still very much available in minimal APIs. So what we're going to request is a command create DTO, and we'll call it CMD create DTO. Okay. And again, by default, this should pick it up from the body, or it should be smart enough to pick it up from the body. If you wanted to use one of those from statements, you could explicitly declare that in here. I'm not going to do that though. Fantastic. So next thing we're going to do is we're going to create a model from our command create DTO. So this is what I'm saying. We need to use a model to inject it into our database. What we have at the moment is a DTO. So we want to create a model from our DTO. So we'll say var command model equals, and we'll make use of mapper, and we'll say we want to map to what? We want to map to a command type. Oh, put that in the side of the brackets. So we want to map to a command, which is going to be this thing here, command model. And what's the source? Well, it's our CMD create DTO. And do we need to pull this in? We do. I thought we'd have had that namespace, but obviously we don't, so that's cool. So we are mapping to a command model from our source, which is our command create DTO, and that should go into here. Fantastic. Now, we will talk about validation a bit later. I will zip my mouth and leave that there for a moment, but that's what we should have at this point in time. We should have a command model, all things being equal. And then all we need to do is we just need to use a repository to put that model into our database. So we will await on a repo, it's an asynchronous command, and we will use create command. And into that, we will just pass our command model. Okay, cold fingers, not typing very well. Now, as I mentioned before, if we just said, okay, that's cool, we've added that in, that's all brilliant, let's just return back, we actually need to return back our read DTO now, that won't work because, as I said before, simply creating a command using Entity Framework will create a command in the DB context, but until you save it, it won't get flushed down to the persistence layer. So we have to make use again of our repository. Again, it's asynchronous, going into our repo, and this time it's save changes. Okay, and we just save changes. Now the other thing possibly I should have done is name this method, actually name both these methods, save changes async. That's really the naming convention that you should be using for asynchronous methods. You should tail them with that. So save changes async. I've not done that. Still works obviously, but just for future reference, I should have done that. I'm just actually using the commands now. It's just reminding me I should have done that. All right, so that's saved our model down to our database. At that point, we get an ID. Okay, so injected it in as you saw when we did it manually, we now get an ID. So we want to now return that back to our user and go, yeah, that was created. And so we want to be able to pass back a command read DTO, including the new ID that's been created. So we have to use mapper once again. So again, I'm kind of doing this step by step. You could probably combine some of these steps, but I just want to do it step by step so it's a bit more clear what I'm doing. So we're going to create a variable called command read DTO, and we'll make that equal to mapper, and we're going to map to what? We're going to map to a command read DTO type. What's our source? Command model. Okay. And you might be going, well, how's command model got an ID? Well, this is a reference type. So basically by creating it from our create DTO, it persists here. We then pass it into a repository. When we save it, that will actually keep a reference to it, and we have the ID of the model. Hopefully that made sense the way I explained it. And then simply we just return it back. So results, return results, sorry, getting ahead of myself, return results. created to say that we've created something, so that should give us a 201 HTTP response. And what do we want to pass back? Well, we want to pass back, I want to pass back anyway, the following. So we're going to use string interpolation. So $, double quotes, API, v1, commands, / curly brackets, command read, dto.id. So that's the route. And then I'm actually passing back the object as well. Okay, so what that's going to do, we'll see it, let's run it. It's actually much nicer than the equivalent that you have to work with in MVC, much nicer. So hot reload, change is successful, that's cool, there you go. So we've just saved that, it was already running, so we should be able to use it now from Insomnia. So very impressive. Let's copy this one here, duplicate it, should I say, duplicate. We'll say create a command, create a command, and we need to change it to a post request. This route is the same, so that's why I copied that one. I'm going to move this down, being a bit what's it, obsessive compulsive. We're going to set our body to JSON because we want to pass in our command create DTO, and what I'm going to do is I'm just going to copy it from here. So I'm not copying the square brackets, I'm going to copy these. I'm going to put it in here. Now you'll remember before I do that, that we don't expect an ID. So I won't even bother showing you the code, but we don't expect an ID. So let's say how to build. Let's change it to building, build a .NET app, and it's .NET build. Okay, and let's see if that works. Method not allowed. That's interesting. So maybe let's just, I'm just going to be, check that, all looks okay. Let me just kill this. Let me run it again. Let's just run it up. I just want to test it wasn't a hot reload that did anything weird there. Let's try it again because I can't really see anything wrong with this. There you go. So that's what I'm talking about. Hot reload can be okay for some things, but for that we got, well, you saw what we got. So stopping it and restarting it, we get our response back. And you can see here, we get 201 created and we have this here. I just want to have a look in the timeline. Yeah, that looks okay. That looks okay. All right. Cool. So yeah, we get our resource back. It all looks pretty good. If you come over to our headers, you can see here that it gives us our location, and this is really what this bit here is relating to. It's telling us where you can find that resource, which is kind of part of the REST specification. You should really, when you create a resource, as part of the return response, you should tell the requester where they can subsequently find that resource should they need it. And so that is what this is pertaining to here, and that is returned back as a header in here. All right, so we'll take a quick pause there and then we will move on to doing our update and delete actions. And then after that, we'll move on to actually doing a bit more of a deep dive into some of the features that are missing from the minimal APIs. But first, we'll do our update endpoint. All right, we're getting close. We only have 2 more endpoints to go, and they're kind of variations on a theme, to be honest with you. So let's crack on with it. So app, we'll do our update one next. So we're using a put request, so map put. Now, again, this is one of the things we'll cover a wee bit later, and that is the patch command. But we'll cover that later, but you can see here we only have put available, and the idea behind the put update put update is that you update the whole object. So we pass our command object in its entirety and update it that way, as opposed to being able to update individual things. But we'll talk a bit about that later. So map puts, this time we are wanting, I'm going to copy the route from here, and let me actually copy this. So I'm going to copy the stuff from our read action or get action where we read an individual resource. And so we are going to expect a very similar thing, which is to expect an ID in the route, which is the ID of the resource we want to update. But additionally, we want to have the body text of the body of the object that we want to update to. So I'm just going to, this is just getting getting to annoy me a little bit. Let me just close this off a little bit and put the curly brackets and the round bracket in. And in addition to passing the ID, which we're going to get from the route, we also want to pass in a command update DTO, and we'll call that CMD update DTO. Okay, so it's kind of an amalgamation of our create that we've just done and also the get command that we've done as well. So we're getting this from the body and this from the route. So in our method, first thing we're actually going to do, and I'm going to copy from here. I'm going to copy this. We're going to do pretty much exactly the same thing. So we're going to, I'll step through it. We're going to create a command object by waiting on our repo synchronously and attempting to get this object from our repository. Now, instead of saying if it's not null, we'll say if it is null, and if it is null, then we will return back a not found. Okay, so hopefully that made sense. So we'll do a database lookup on our object. To get our object, we want to actually work with our object, our model, using this method. If it's not found, then we just return back not found. I think that's fairly self-explanatory. So we continue on. This command is in the database, it's in the repository, so we want to now update it. And when we do that, no surprises, we use mapper. And we use it in a slightly different way to the way we've used it before. So we just use mapper directly, and we say mapper map, and we say what is the source, which in this case is the command update DTO, and what is the target? It's command. There we go. I'll close that off. And then all we need to do, let's get rid of that tooltip, is we just need to save our changes. Save changes. Okay. Now you'll notice that, you know, for our create command, we actually had a specific command on here for creating a command, and when we do our delete, we'll actually have a specific command to delete a command. For our update, we don't actually need anything, because by virtue of the fact that we've retrieved this command object from our repository and we're just doing an update to it, well, yeah, we're doing an update to it here and saving the changes here, we don't actually need any other repository method to do that. And then all we want to do is we just want to return a result, and I'll say return results, and this time we'll say no content. Now, there's various ways you can do this. If you wanted to pass back the updated object, you could, of course, do that. I'm just going to say no content, and if we want to look at that object subsequently, we can do a get request. So hopefully that made sense. Let's save that off. Let's kill this. Let's run it again. We're not using .NET Watch. And wait for that to run up. Fantastic. And let's use Insomnia again. So we will duplicate this. I'm going to say update a command. Fantastic. We will change this to put request. We're going to, let's just get all our commands. See, we should have 2 in there now. We do. So let's update this to, actually let's update this first one to, instead of it being running an application, let's say .NET Watch, so that's ID1. So back over here, we'll add in our route to 1, and then we'll pass in our DTO. So we'll say watch, hot reload. I'll be facetious and say maybe, brackets maybe, and then .NET app, and we'll say .NET Watch. Okay. So that should update in situ our object. Send that over. Great, we get a no content. If we do return all commands, there we go. We get, this has been updated to hot reload. Being a bit cheeky there. All right, cool. So maybe what we do is, rather than taking a quick break, let's just push on to the end, and we'll do our delete endpoint as well. I'm sure you're getting the hang of this now. Now, just before we do that, I mean, you can see here we are building up some code, but there is still less code than using a controller. And more importantly, one of the benefits of this approach is you're really just using what you need, and that is defining endpoints. You don't have a lot of other waffle around the edges. All right, so let's go on to delete. So API app map delete. Not getting my IntelliSense map delete. There we go, it is there. And we want to pass in something very similar to this here. Whoa, not all of that, of course. Up to about here. So we're going to be passing in just an ID of the thing that we want to delete. And yep, that looks cool. Close that off, goes to, open curly brackets, close off the round brackets, add a semicolon as usual. So again, yeah, we're going to this route here to delete this resource, and we're expecting that passed in. Hopefully makes sense. And then we will do exactly the same thing here. So I'm just going to copy this in its entirety. So if we want to retrieve that command from the database, if it's not there, then we just return a not found. Otherwise, we're going to use a repo. We're going to delete command, and we're going to pass in the command that we want to delete. And you'll notice we're not awaiting on this because this command is not synchronous, as you'll remember, so we can just call it directly like that. But what is asynchronous is we do still need to save, so we'll say await on our repo, and we will save changes. And that will save and flush the change down. And then we will just return results. No content. Fantastic. So that should work. Save it off. Looking good. Run it up. And we will destroy some stuff here. And let's put a new, let's duplicate this one. Delete a command. Fantastic. And we'll change this to delete. And we'll leave that as is. We'll take the body out. We don't need one, so no body. And we'll just send that off and we'll delete number 1. No content. And if we go and get all our commands, we only have one, so we have deleted our resource. So that brings us really to the end of, not the video by any means, but the end of our build of our minimal API. And you can see how quick and easy it was to build a minimal API using those endpoints. All the Automapper stuff and the repository stuff, and that was all kind of building up to doing the endpoints. You saw how quick the endpoints were to build out. So a nice lightweight methodology. However, what I'm going to do now is we're going to return to our pack and we're going to look at the things that I've called out as missing, and we're going to do a bit more of a deeper dive contrast and compare between what we've just built versus what we have in our MVC API. So we'll do that next. So, as mentioned many times before, minimal APIs do not have a controller, and we've covered that in great detail already, but now we're going to delve into what that really means and look at 4 areas that I've picked out that I want to look at in a bit more detail. And yes, as it also says there, minimal APIs do not use the MVC framework either, which kind of leads us on to this discussion. So what that really means is minimal APIs don't support model validation by default. You can validate your models using minimal APIs, but you have to add it in explicitly. It's not part of any built-in framework. You would have to pick a framework in which to validate models or roll your own. They don't support JSON patch. We'll talk a bit more about that in a minute. And again, we've got demos for all of these. I've actually got practical demos for all of these things if you don't really know what they are. They don't support filtering, and they don't support custom model binding, and specifically support for what's called iModel Binder. But again, we've got a bit of an example of that. And if we just pop over to this article here, and that's really where I referenced a lot of this stuff from. And there's a lot more points here. I mean, they're covering the filtering stuff here, they're covering model binding here, model validation here, JSON patch. There's a few other things in here that I left out that I didn't feel were as important to me, but if you're interested, you know, I'll put a link to this article and you can have a look at all the differences, but I really wanted to focus on those 4 that I have called out. So the first one we're going to look at is, not that, is filtering. Filtering is the first one, and the way I'm going to tackle each of these 4 is kind of in the order in which a request would propagate its way through an API. So what are filters? They basically, in a long and short of it, is they allow you to run code before or after stages in what's called the filter pipeline. And we've got a bit of a diagram of what the filter pipeline is on a couple of slides' time. And each filter is executed at a different stage in the pipeline. So you have things like authorization filtering or resource filtering, action filtering, exception, and result. So filters can then be scoped either globally to the entire application. So you can create these filters and apply them across the app, or just to a controller, or just to an action. Okay, and I've got the example I've got, we've scoped it to a controller. And you can have synchronous or asynchronous versions of those filters as well. So just in terms of what we mean by filter pipeline, it's maybe not something you're that familiar with as opposed to the request pipeline. So what you see on screen here is the .NET request pipeline that you're probably a lot more familiar with, and you can see things that we've even come across in our minimal API, things like HTTPS redirection. We're not using authentication or authorization, but these are basically the steps, some of the steps that you can have within your request pipeline. Not all of them, I hasten to add, and you can even add in custom middleware to your request pipeline. And the request comes in, propagates its way through the pipeline, and then will propagate back through the pipeline as a response. And you said you can add your own custom middleware. That's not really what we're talking about though. We are talking about the filter pipeline, and the filter pipeline is something that really comes with MVC. And you get all this stuff with the filter pipeline. And you can see here in black, the order sequencing of the different filters you can have: authorization filters, resource filters, action filters, so on and so forth. And we also, as part of this, we have the model binding stuff and the model validation stuff as well. So this is really the filter pipeline that just isn't available with the minimal APIs, as opposed to the request pipeline, which absolutely is still part of the minimal API framework. And we've seen some of these things anyway already. So let's take a look at our code. And as filtering just isn't supported in minimal APIs, we have to look at our MVC-based API. So we have a controller called commands controller, which is sort of analogous to what we've done in our minimal API, and we've actually had a quick look at this already. But what you'll notice is that I've decorated this controller with something called a service filter attribute, and I've given it this type here, test async action filter. And this is our test async action filter here. Okay, it's just a class that inherits from whatever from whatever filter type you like, and this is an action filter in this case. And into it, this is an asynchronous version. Into it we expect a context of the request, and then a delegate to the next thing being called in the filter pipeline. And all I'm doing is just writing out to the console in red what happens before the request has executed, and then what happens after the request is executed. And I've also just pulled out, just as a point of reference, just pulled out the query string of the request. So this is stuff that happens before the request is dealt with, and this is stuff that happens after the request is dealt with. So the use cases for this are maybe many and various. I mean, it really depends whether you actually have a need for this to actually do something before the request is dealt with or after. That's what filtering is used for predominantly. So the only other thing we need to do is in a program class, we just need to register that action filter for dependency injection. So to see what that looks like, we'll just do a .NET run to run up our API, and we'll come back over to Insomnia. And this time I'll make sure, I'll call this off screen because I want you to see the command output, but we're just going to call any one of these commands. Doesn't really matter which, get all commands. I'll just call that off screen. And you'll see what happened there. Well, actually, if we pull Insomnia back onto the screen, we get our response back. But more importantly, from the perspective of talking about filters, here we have an action filter that's doing something before the action. There is no query string according to this, because we didn't actually have a query string. So maybe if we try, so let's just put a query string on here. Test equals hello. Let's try that. Won't impact our API call. There you can see we have a query string being pulled out. So you can do things like that. You can interrogate what you're getting passed through, not just as a query string, but anything else you like. Then you can see here there's the actual lookup in the database. Ignore this, this is just something I've been playing around with. And then we have a green output dictating that the request is finished. Okay, so that's filtering. Yeah, that's filtering in a nutshell basically, and it's not available in minimal API. So whether you think that's a hardship or not, I'll leave that to you, but that's the first thing we're going to cover off by way of a difference. Next thing we're going to look at is custom model binding, so we'll do that in the next section. All right, so the next thing we want to take a look at is custom model binding. And for me personally, out of the four things that I've picked, this is the thing that's least important to me as something that's missing from minimal APIs, but it's something other people use, and I thought it's worth definitely covering and exploring in a little more detail. So again, can't really demonstrate it in our Minimal API. Minimal API supports model binding, as you've already seen, but in terms of custom model binding, it's just not supported. So I can't show you that. I can't show you something that doesn't exist in Minimal APIs, but I can show you it in our MVC-based API. So we'll do a bit of a demo of that. So custom model binding, and more importantly, iModel Binder, allow controller actions to work directly with model types rather than HTTP requests. So as we've seen with our Minimal API, it's a request comes in, binding happens at that point, and everything seems to work okay. What custom model binding allows you to do is actually bind to models before dealing with a HTTP request. Okay, and we'll see that working in a minute. It can be used to use the more complex binding scenarios. So maybe whether you have to do data lookups before passing it on to the controller action or something like that. Yeah, if you need to transform data or something else like that. The default model binders support most common .NET types, so they meet most developers' needs. And certainly in my case, I've not used custom model binding in the real world at all. And yes, we've already seen this filter pipeline. Model binding occurs before model validation, and we're going to cover model validation in the next section. So, I'm going to take you through a bit of an example, but I will also run through this in code as well. And just before we go on, I have taken this example from this Microsoft article, and I've put a link in the description below. So what we have is a controller, and for this example, I've created a totally separate controller that just works with an entity called platforms. Doesn't matter, not really relevant. And in that controller is one action, as you can see on the screen there. Now, the action itself inside it, what it's doing is really not that important. What is important is the fact that we have this model binder attribute inside our action signature here. And what it's really doing is it's going to make use of a custom model binder to take the ID that's passed as part of the route, and it's going to do something with it and then bind the result to a platform object here, and then the rest of the action continues as normal. So it's a bit convoluted. I actually struggle with the use case personally, but nonetheless we'll go through it. So what this requires is a custom model binder that implements iModel Binder. And so as I've said, because we're using custom model binding, that ID will be taken, used by the model binder. It will reach out to a DB context, which will hopefully find that model in our data source, return it back, and then bind it to the controller action here, and in particular the platform object that it expects. Okay, so a little bit convoluted. And the only other thing to note is the actual platform model itself has to be decorated with this model binder attribute, and we tell it where it can find the custom model binder, in this case platform model binder. So I don't really like it, to be honest with you. I find it a little bit convoluted and not terribly useful, but you may disagree with me, of course. So over in our MVC API, here's our platforms controller, and you can see we have an action that you have already seen before. We have a route to it, and yeah, you've already seen this bit. What you've not seen is the custom model binder. If I select that, which is here, it's just a class that implements iModel Binder. It uses constructor dependency injection to get access to our DB context, and then it has to implement this method here, bind model async, and we get a binding context as part of that. And then the rest of the code is basically just working effectively with that binding context, and then using our DB context to get model data out and bind it ultimately to our result, which, if we come back to our platforms controller, should hopefully be this thing here. So a bit convoluted, not terribly nice, to be honest with you, but I thought I would go through it. So what I want to do before we do anything else, this controller doesn't have any methods that return the platforms, but I do want to just show you the platforms that are in the table. So we get everything from platforms. Oh, I think I've connected to the wrong DB. Let me just connect in again. Okay, and to our database, and we should have a, yeah, this is a separate database to the one I was using for our minimal API, so that makes a bit more sense now. Let's save that, and let's just do a new query. And we'll select everything on platforms. Cool, so we get 3 platforms in here, and so we're basically going to pass one of these IDs, resource IDs, in the route, and the model binder, the custom model binder, will actually go away and pull this model out from using a DB context and then pass it on to the action. And all the action does is check to see whether it's null or not, or if it's been returned, then it just returns it. So let's come back over here. Here's our call. So again, it's going to API v1 platforms binder and then passing in an ID. So if we pass in an ID of 1, and we send that over, it just pulls out, just get rid of that, it just pulls out the relevant model. That's it, that's custom model binding. Personally, don't find it that useful, not in minimal APIs, don't think it's a big deal. Anyway, that's that. Next thing we're going to take a look at in the next section is model validation. All right, so let's move on to take a look at model validation. So what is model validation? I'm sure you've probably seen this to some extent in your journeys, making and working with APIs, but we'll just go over it here. So model validation occurs after model binding. So we had a quick look at custom model binding in the last section, but what we're really talking about here is model validation now. And it reports business rule type errors. Okay, so typically, and we've got an example coming up, if you try to pass a string of a particular length that's greater than the maximum allowed by the model, then you'll get a validation error. And you get all this out of the box with MVC APIs using the API controller attribute. It kind of gives you a lot of this stuff by default. A really important point, and we'll show you validation not working out the box with minimal APIs, you can add validation into your minimal APIs. It just doesn't come as standard. So that's the really important point I want to make. So you can use libraries like Fluent Validation or Minimal Validation to add validation to your minimal APIs. But just to demonstrate what I mean, this is our MVC based API. If we come back to our let's actually look at our DTO. So our command create DTO. In this case, I've just been playing around, obviously. The maximum length allowed is 7. So if we try to pass in anything other than 7, it should give us some kind of validation error. So if we come back over to Insomnia, and again, we're using our MVC, we go to create a command. And what was it that was 7? It was the platform name. So that will be okay. Well, let's try that. That works okay, and then if we do something like .NET Core version 6, what do we get? We get a validation error, so we get a 400 bad request, and it even tells us the field platform must be a string or array with a maximum length of 7. Brilliant, great, wonderful stuff. If we come back over to our minimal API and we run the same thing, so where's our minimal API? And I think in this case, we were using a slightly different value, but it's the same principle. We were using a platform size of 5. If we try and run that with a size of greater than 5, then, well, you'll see what we get. So if we just do a .NET run, just to run up our API, and we come over here, and let's make sure we call the minimal API this time, and we pass in something greater than 5 characters, send that across, we just get a horrible error, okay? A horrible error about SQL Server not liking it. So validation is not included by default with minimal APIs. Now, I don't suggest for 1 minute that, well, you walk away from that and go, well, it doesn't support validation. You would have to add validation. And there's quick ways you could do it by just even using try-catch statements or something like that, or you could use something more sophisticated, like one of the libraries that I'd used. And for me, validation is the thing I would definitely be focusing on if I was building something with a minimal API. I absolutely would want to include it. And I might even do a dedicated video on that subject. But again, just wanted to call it out as one of the important things that is not there out of the box with minimal APIs. So in the next and final section, we're going to take a quick look at the patch endpoint. So we'll do that next. All right, so in this last section, we'll take a quick look at the patch endpoint, and I don't have any more slides. You'll be very pleased to hear. We're just going to jump into an example of what it is. So here we are back in our MVC based API, and if we come into our commands controller, you will see that we have, if I scroll a bit further down, we have a patch endpoint. So HTTP patch attribute is decorating this particular action result here. And I'm not going to go through it in massive detail. If you want to know how to build APIs with a patch endpoint, then check out my full ASP MVC API build video. Although it's using Framework 3.1, it's really not changing that dramatically much, even though we're using Framework 6 now, so we'll describe that in full detail in there. But what I want to call out here is that the patching uses something called a JSON patch document. And what the JSON patch document allows you to do is specify individual attributes, among other things. It allows you to do a lot of things, but in this use case, what I'm going to talk about is it allows you to update individual attributes or do things at an individual level. So you're not passing an object as such, you are passing a patch document. And then, you know, there's a range of things that happen within here. You have to actually bring in some other bits and pieces up here. You have to add Newtonsoft JSON serialization package, and you have to add that to your controllers. And you can see it's quite a bit of work to add it on top of the sort of regular endpoints. So just to show you what that looks like, we will run this up. So .NET run. Again, this is our MVC API. And we'll have a quick look at patch documents. So over here, make sure we go into our correct collection. Here's patch. So you still pass over the ID of the resource that you want to change. So let me just get all our commands. There are 3. So let's say we wanted to change item number 2, and instead of it being build the .NET app, we'll change it to something else. And we just want to change the how-to attribute. Let's say we don't want to change, we want to leave this stuff alone, okay? And again, just to refresh my memory, with put, you pass the whole object. So theoretically, you should update the whole thing. It's a full update, whereas patching, as the name suggests, is just, you're just patching it. So we'll change that to 2, and then you can see here, this is this patch document, and there's various ways you can construct patch documents, but what we're saying is we want to replace the how-to element, and what did we say? We want to change it to, I don't know, doesn't matter. Watch a .NET app, doesn't really matter. Just take this out. And what should happen is, only that one attribute will be updated. The other 2 remaining attributes, whatever they happen to be, platform and command line, will remain exactly the same. It will just be the how-to element that gets updated. So again, we get our no content. If we pull this back, we should see this change here. Indeed we do, and these other 2 things are left alone. So that's what patching is. It's nice, but to be really honest with you, in the real world and the APIs I've come across, I don't see patch being used that much. What I do see is people using put requests and kind of bastardizing them slightly to kind of work a bit like patch. So instead of passing the full object over, they just pass over the attributes that they want to change. And in the back end, it just perhaps just maps those updates onto the model, for example, and doesn't bother updating the other attributes that it doesn't need to. So there are ways around it without patch being officially supported in minimal APIs, but to be honest with you, I don't actually see it being used that much. So those are my 4 main differences between MVC APIs and minimal APIs. We'll take a quick pause and I'll come back with a bit of a wrap up and some conclusions. So we'll do that next. Well, before we jump to the conclusion, I do want to just say one more time thank you for joining me here today on our journey through looking at minimal APIs. It's another relatively long video, so if you made it this far, well done and congratulations. In terms of which API pattern to use, minimal APIs versus MVC APIs. I'm going to say the same thing that I usually always say, and it might sound like a bit of a cop-out, but that decision is entirely up to you, and it'll be driven by the use case that you are solving for. So in some instances, you may choose minimal APIs, in others, you may choose the more traditional MVC API approach. For example, for me personally, in my teaching on YouTube, I'm going to, and have actually started using minimal APIs as the base project, just because they're so much quicker and easier to get up and running. So maybe if you're doing something similar, or you want to stand up a POC really quickly and just hack out some quick code, minimal APIs are of course excellent for that. However, possibly if you want to maybe build a more enterprise level API with a lot more features, maybe such as custom model binding or filtering, then your choice is more limited and you really need to go down the MVC path. Pragmatically speaking, I don't think the divide between the two patterns is actually that dramatically different, and I think you can, as you can see, probably achieve pretty much the same or very similar results with both, in fact. For me personally, probably the biggest thing that if I was using the minimal API pattern for a real API build, the one thing I would definitely introduce is model validation. And so I'm thinking one of my next videos is actually going to be how you can use model validation with minimal APIs. But once I think you tick that box, for me personally, I don't think there's that much difference between the two, and I would happily use either. So I'd be interested in your thoughts on minimal APIs, whether you think they are something you would use or whether you're going to stick with the MVC based API. Put comment below. I'll be really interested to hear back from you on that. Anyway, I'm going to leave it there for now. Thank you so much again for joining me. My Patreon supporters, your names are coming up at the end of the video, as always. And until the next time, until I make my next video, please all stay very, very safe, and I will see you all, hopefully, next time. soon.